Welcome back to Advanced Skills Learning. Retrieval-Augmented Generation, or RAG, is often presented as the solution to hallucinations and unreliable LLM answers. The idea sounds simple: retrieve relevant information, pass it to the language model, and get grounded, accurate responses. And in demos, RAG usually works great, but in real-world systems, RAG fails far more often than teams expect. In this video, we're going to look at the most common RAG failure patterns you see in production systems, why they happen, and how to recognize them early, before users lose trust in your application. One of the biggest reasons RAG fails in practice is that retrieval is treated as a solved problem. Teams focus heavily on the LLM, embeddings, or the vector database, but underestimate how messy real data and real user queries actually are. Retrieval does not automatically mean relevance, and data does not automatically mean knowledge. The first common failure pattern is retrieving the wrong chunks. Vector search is optimized for semantic similarity, not correctness. That means the retriever often returns chunks that sound right, look related, and feel relevant, but are actually wrong for the specific question being asked. Without constraints like metadata filtering or domain awareness, the system confidently feeds incorrect context to the model. The second failure pattern is missing critical context. This usually happens because of poor chunking strategies. When documents are split too aggressively, related information gets separated into different chunks. The retriever may fetch one part of the explanation but miss the key condition, exception, or dependency that actually makes the answer correct. The result is partial truth, which is often worse than no answer at all. Another very common issue is noisy context injection. Many teams assume that more context is always better, so they retrieve a large number of chunks and send them all to the LLM. In reality, this overwhelms the model with low signal information. Even if the correct answer is present somewhere in the context, it gets buried in noise, and the model struggles to focus on what actually matters. Quick check, 2 seconds. What usually causes noisy context in a RAG system? Is it too few chunks, too many irrelevant chunks, or larger embeddings? Keep your guess. The answer is too many irrelevant chunks. The next major failure pattern is ignoring metadata altogether. In enterprise systems, documents often span different domains, time periods, versions, or policy scopes. If your retriever doesn't filter by metadata like document type, effective date, region, or source, it may retrieve technically valid information from the wrong context. This is one of the most common reasons RAG answers feel confident but incorrect in production. Another issue is query and document mismatch. User questions are rarely clean, precise, or perfectly phrased. Many are vague, overloaded, or ambiguous. If the system sends the raw user query directly to the retriever, it may retrieve content related to the wrong intent. Without query rewriting, intent detection, or clarification, the retriever simply guesses, and often guesses wrong. Many people are surprised to learn that hallucinations can still happen even with RAG. RAG reduces hallucinations, but it does not eliminate them. If the retrieved context is incomplete, unclear, or conflicting, the language model will still fill in the gaps. When context quality is low, the LLM falls back to its training and produces answers that sound plausible but are not grounded in the provided data. Quick check, 2 seconds. RAG hallucinations usually happen when the LLM is too large, the vector database is slow, or the retrieved context is incomplete. Keep your guess. The answer is when the retrieved context is incomplete. Another critical failure pattern is the lack of an evaluation loop. Many teams deploy RAG systems without measuring retrieval quality at all. There is no tracking of precision, recall, or answer faithfulness. Without feedback and metrics, teams are effectively flying blind. The same failures repeat silently as usage grows, making the system harder to debug over time. In production, these failure patterns show up in very familiar ways. Users get inconsistent answers to similar questions. Trust in the system slowly erodes. Teams hear comments like, "It worked yesterday," or "Sometimes it's right, sometimes it's not." These are not random bugs, they are predictable symptoms of retrieval problems. The key takeaway is this: most RAG failures are retrieval failures, not generation failures. Improving chunking strategies, adding metadata filters, refining queries, limiting noisy context, and measuring retrieval quality will usually deliver far bigger gains than switching to a larger model. If you want reliable RAG systems, focus less on the LLM and more on the data, constraints, and evaluation around retrieval. That's where real-world RAG systems succeed or fail. Thanks for watching Advanced Skills Learning. If you found this helpful, please like the video and subscribe for more GenAI explainers, practical architecture patterns, and quick quizzes to test your understanding.